Hi friends, in this video we will study about Earth magnetic field or geomagnetic field. Why does a freely suspended magnet always point towards north? Answer is yes. Do you know the answer? Okay, at the end of the video you can easily tell that answer. So let us listen that video. We begin with the layers of Earth. This figure shows the several layers of the Earth. The Earth's surface is the top layer, that is called crust. Beneath the crust, the layer mantle is there. Below the mantle, outer core presents. This outer core consists molten metals like iron and nickel. When Earth rotates, the molten metals also rotates. The center of the Earth is inner core. This is also made of iron and nickel, but is in the solid form. What is the principle behind of Earth magnetic field? For that, we must know about that the relation between electric field and magnetic field. Electric field is moving in a direction. The magnetic field is created in the perpendicular to the direction of the electric field at a particular point. That is, the angle between electric field and magnetic field is 90 degree. For that particular surface area, the shape of the magnetic field is circle. For throughout the length of the wire, it has a cylindrical shape. Look at that figure. 3-axis graph is shown. Now, electric field is appearing in vertical in the sine wave pattern. You can see magnetic field is appearing in horizontal in the sine wave pattern. We will see the same concept in motion, that is electric field is in vertical direction, magnetic field is moving in horizontal direction. How Earth behaves as magnet? See, our Earth is revolving from left hand side to right hand side and rotate about an axis. This is called axis of rotation. And above we have geographic north pole and below we have geographic south pole. As Earth rotates, the electrons of iron and nickel also rotates in the outer core. We know that the electric field moves in a certain direction and magnetic field is created in the perpendicular direction. Hence, the magnetic field is moving in vertically, that is perpendicular to the electric field. So, the magnetic lines of force from north pole to south pole of a bar magnet, which should be assumed inside the Earth. So, from this we conclude that Earth behaves as a bar magnet. Here the poles of Earth magnet can be identified by the direction of magnetic field, which is always moves from north to south. So that geographic south pole, Earth magnet has a north pole. At geographic north pole, Earth magnet has south pole. Just draw a earth magnetic axis, and above we have north pole, that is magnetic north pole. That means the compass needle seeking the north pole. On the below we have magnetic south pole. The angle is developed between these two axes, that is geographic north pole and magnetic north pole. That angle is denoted as theta, which is called as dip angle. Dip angle is the angle between geographic north pole and magnetic north pole. Dear friends, in the examination point of view, we are going to learn how to draw this earth magnet and magnetic field. Initially, draw a circle with a shading, and then you have to assume that it is an earth. Draw a slope line as shown in figure. This is axis of rotation or geographic north pole. Below, you have to mention it geo south pole. Then you have to draw a rectangular box for a magnet and mention the poles. The top side you have to mention south pole, and bottom side you have to mention the north pole. Then draw a slope line which passes through the magnet, that is called the magnetic axis. Above magnetic north pole, below you can write as magnetic south pole. Mention the dip angle with value 15 degree. Then draw the earth magnetic field from north pole to south pole of earth magnet. Draw more magnetic lines of forces from north to south. Then mention average earth magnetic field is 40 microtesla. After do this figure, write some points about earth magnetism. The earth has a magnetic field due to electric currents in its liquid iron core. The shape of earth's magnet resembles that of an imaginary Bohr magnet which buried at its center. This was concluded by William Gilbert. The earth's magnetic field varies from place to place. The value of the magnetic field is around 40 microtesla. Dip angle is the angle between geographic north pole and magnetic north pole. This angle varies at different points on the earth's surface. Now, theta is equal to 15 degree. Now, let us see the importance of earth magnetism. Earth's magnetic field serves to deflect most of the solar wind, which would strip away the ozone layer. So, it protects the earth from harmful UV radiation. Humans have used compasses for direction finding since the 11th century AD and for navigation since the 12th century. Now, the previous question. Why does a freely suspended magnet always point towards north? Can you tell the answer now? Yes. The earth itself behaves as magnet. The earth's magnetism is due to magnetic effect of current which is flowing in the liquid core at the center of the earth. The shape of earth's magnet resembles that of an imaginary Bohr magnet which buried at its center. The south pole of Earth's magnet is in geographical north, so it attracts the north pole of suspended magnet. The north pole of Earth's magnet is in geographical south, so it attracts the south pole of suspended magnet. I hope that you got the points. Thank you.